Okay, so up till this point in the year, we've talked about atoms being neutral. And atoms being neutral means that they have the same number of protons and electrons. Protons being positive, electrons being negative. So, so what is an ion? Well, an ion is an atom, or sometimes group of atoms, that has a positive charge or a negative charge. So that has a positive charge. So it has a positive charge. Well, if it has a positive charge, we can't change what's going on in the nucleus. We can't change the number of protons. So it has a positive charge. That must mean it lost electrons, or a negative charge because it gained electrons. So an ion is an atom or group of atoms that has a positive charge or a negative charge because it has gained or lost electrons. Now, a cation is positive ion. So that means it has lost electrons. Now you're going to see my spectacular artistic skills. So here's how you remember it. This is a cat. Let's see, how should I draw this? All right, that's my wonderful cat, although those eyes are creepy. And then here's the eye. So it's pronounced cat eye, and then on. You might want to be tempted to pronounce it cation. It is not cation. It is a cation. Now, the way you remember, yeah, it's not like vacation. So the way you remember, cats have paws. So cations are positive. Cats have paws, get it? They're positive. Ah, spectacular. The word below is not anion. It is anion. So, I'm not going to draw a picture of I don't know how I would do that. So, anion. And this is a negative ion, which means it has gained electrons. And cations are almost always metals. And anions are almost always nonmetals. And this has to do with the fact that nonmetals have higher electronegativity. They're stronger. They're going to rip the electrons away. Metals have weaker electronegativity. They can't hold on to their electrons. They will be stolen by the nonmetal atoms. So the charges of these ions are very predictable, with a few exceptions. This is one of them. We're going to call it kind of an exception. It's one of the reasons that if you look at your chart, hydrogen is a nonmetal. So it can act like -1. Generally, it doesn't really act, well, it can act like +1 when we talk about acids and stuff. So H we're not going to talk about much in terms of ions. So we have group 2, group 3, group 4, group 5, group 6, group 7, group 8. What we see is so these are metals. They are positive. Hey, what do you know? Down the column, down a group in the periodic table, they have the same charge. So lithium is +1, sodium is +1, and potassium is +1. They all lose their one valence electron. Beryllium, magnesium, calcium have 2 valence electrons. They lose their 2 valence electrons. But when we get to the nonmetals, well, it's a little trickier. Group 8, the noble gases, they do not form ions. But we see fluorine has a charge of -1. Everything else in that column, called the halogens, all have a charge of -1. Oxygen, everything in that column has -2. Nitrogen, everything in that column has -3. So we tend to not talk about group 4. It's not that they don't make ions, but they tend to not make ions. They'd have to gain or lose too many electrons to make it feasible for them. Okay, so how do we represent ions? So if we have a lithium atom with 1 valence electron and a fluorine atom with 7 valence electrons, well, remember, lithium, very weak hold on its valence electrons. Fluorine, a very strong hold. So what's going to happen is fluorine's going to come along and actually steal. It says transfer, but we're going to call it steals. Fluorine steals an electron from lithium. So how do we write this? Well, now I'm left with lithium that has 3 protons and 2 electrons. So the net charge is 1 plus. The way we write that is Li plus. So fluorine had 9 protons. Now it has 10 electrons. So its charge is 1 minus. So we write it here. Now the way we write the charges, we always write the charge as a superscript. Charge written as superscript. We can also have what's called a Lewis dot representation. And the way we do that is, this will be done a lot more frequently when we talk about molecules. But so Lewis dot symbol. Step 1, you write the symbol for the element. Step 2, you put 1 dot for each valence electron. So for example, so we have fluorine. This is a fluorine, neutral fluorine atom that I'm going to do first. So the way I do it, and this, the Y will be evident soon. I start on the top. I know I look. Fluorine has 7 valence electrons. Okay, so I put 1 on the top, and then I go 2. I put the second one on the right side. 3 on the bottom. 4 on the left. 5 on the top. 6 on the right. 7 on the bottom. Now, well, fluorine gained an electron. So now what I have is fluorine with 8 valence electrons, because it gained that electron. So this is the fluorine atom. I have a hard time spelling fluorine for some reason. Okay. So what happens is ions tend to look like noble gases. You don't need to copy the stuff down on the left, but ions look like noble gases. And this is really in terms of their electrons. So lithium loses an electron, so it has the same electrons as a helium atom. Fluorine gains an electron, so it has the same electrons as the neon atom. You're not changing the identity. This does not change the identity. So I'm going to ask you, why does it not change the identity? Take about 10 seconds to think about it. When it loses electrons, why does it not change the identity? And it's because the number of protons does not change. Now, so we say it looks like fluorine gains an electron, it looks like neon. It's not neon. It's still fluorine, but it just has the same electron configuration, we say, as a neon atom. So what we call is we have the octet rule. Which says when atoms form ions, and we're going to use this for molecules too later on in the year. When atoms form ions, they tend to end up with 8 valence electrons. So the exceptions to this are Li and Be, which end with 2. Also, the exceptions are the transition metals in the middle, but we're not going to discuss that. So the octet rule, when atoms form ions, they tend to end up with 8 valence electrons. We call that the octet rule. So wrapping up, how can valence electrons and electronegativity be used to predict the result of combining two elements? So non-metal atoms are stronger. They take electrons away from metals. When atoms gain or lose electrons, they form ions, so they're no longer neutral. Ions are atoms that carry a net positive or net negative charge. When atoms lose electrons, they have a positive charge, and they're called cations because they're positive. When atoms gain electrons, they have a negative charge and are called anions. And ions have electron arrangements resembling those of noble gas atoms.